Welcome to our SEAM studio here in the heart of the Free State in Bloemfontein. This channel serves to bring you only the best in aviation safety. Join me now as we cross over to one of our aviation experts, Charlie Murray.
Well, welcome again to the SEAM studio on the fifth delivery in the series on stalling. And now we're going to tackle the problem of the VN diagram. We're going to get right into the VN diagram, and here the V, velocity, let me go there, that's a little bit easier. The V, velocity, you can see goes about the equivalent airspeed square, which is on this line here, and the load factor, it's played off on the side here. So if we can play these two off during this presentation, then we should be able to construct a flight envelope. Just one or two things to make sure. Vm, maneuver stalling speed, equals basic stalling speed square root of n. And we said in our example, the basic stalling speed is then 50, and that will always be at 1. So that's the first point. If I now go and I actually use this formula, in other words, remember the formula Vm equals Vs, I nearly said Vm, Vb, all right, square root of G or N. All right, so what I've actually done is I've worked out a square root of 2 times 50, and I got it there. And I've done that at 3 Gs, and I've done that at 4 Gs, and so forth until I got to the top. All right, so that was how this one was determined. Just a little line to say that it's there. A couple of important things here to come is then we obviously got a maximum G, and the maximum G according to the aircraft's book or the handling notes is 4 Gs, and there you can see I put it in, and in other words that is the maximum G loading. And then you'll see I've carried on, there is extra, and we'll get to there just now. The thing about the negative is because of the camber of the aircraft and the angle of incidence and a lot of stuff, this one I didn't work out. I just put it in, and for now, more worried about the positive G, and you're definitely not going to fly aerobatics and high negative G maneuvers in the typical aircraft that we're talking about here today. The next one that we have to do with is the VNE, velocity not exceeded. And I put a line in here and said 143 days. Where did I get the 143 knots from? I just decided on 143. Okay, it could have been anything. So this is just to make up and the principle of what we're busy doing. Now, what I've done here is to look at the minimum G, that line in, the maximum G, that one, and here. And now all of a sudden you can see here is starting pardon me, that is where we start the flight envelope. That is the part there that we are after. All right, now what we see here is that we talk about the buffered corners. You'll see, remember, this was straight, and this was straight there, and this is now cut off, and this is cut off, and that is because at that high G loading and that high speed, that is a very dangerous corner, and then they cut the corners off for us to carry on from there. All right, so the next, I put a little bit of a rolling G limit in here. You won't necessarily find it on your aircraft, it isn't there all the ways, but for the more aerobatic aircraft, you will get your rolling G. But what I would like you to notice here is outside you get into, this was the alpha range or the flight envelope, all right? And when you go outside here, you go into the beta. It's just the Greek alpha, beta, gamma. A, B, and you'll see just now, well, not C, but gamma. Alpha, beta, gamma. Beta range is where you get distortion. Now, what they do in design is that they actually use, if I loosely can call it, the fudge factor. The fudge factor in this case, where you've got your safety margin, is 50%, or the factor is 1.5. In other words, if the maximum G's is 4, 1.5 times 4 is 6, and that. So anything in here, you're going to get distortion. Anything beyond this, you're going to get breakup, and that is then the gamma range. All right. Now, this is the one that concerns me the most, because a lot of accidents actually happen here. Sometimes we venture in here and we've got a problem, and we venture in here, there's not that. But we seldom, not seldom, frequently, we actually end up in this range, in the gamma range. And the problem is, this is only a fudge factor of around 10. That is so little. What happens there? Well, this, after here, the aircraft can develop flutter. Okay, torsional, flexural flutter. It can have short period longitudinal oscillations. There are many things. I don't want to get into this, but I need you to understand that once you're in a flutter phase, this is where you're going to pick that up. And sometimes you say, but I've gone there and I didn't pick up flutter. Well, you're lucky. Because if you're in there and you do a hard maneuver, it will be the onset of flutter. Okay, so now you already see that once you happen to find yourself in that area, just be very, very careful not to get such a fright and yank it out there. All right. So here is the full flight envelope now. This is where we want to operate the aircraft in. And as long as you're here, now for any speed, you can see, all right, if I fly at 90, where am I going to stall? I'm going to stall there. If I fly at 70, I'm going to stall at 2 Gs. So if I'm going to do a continual 60-degree bank turn, I'm going to make sure that the speed always stays above 70. And I'm not going to pull it beyond that, because if I pull it beyond that, it is going to stall. I'm not doing this to scare you. I'm doing this so that you can understand the irresponsibility of just doing what you like. The aerofoil is going to react the way that science has decided it's going to do, and it didn't ask you for permission. So if you scratch the cat, it's going to give you a whack. All right. Let's look at the meaning then of this. What do we get from it? There's a lot. Basic stalling speed. Stalling speed at all speeds. Velocity not exceeded. What are the fudge factors? The aircraft will accelerate it. What? Ooh, look at this. Aircraft will get accelerated metal fatigue if operated in the beta range. So if I go back to the previous slide, which I will do, if you in here, the aircraft, the fatigue will be quite a bit faster. So don't play there. You get away with it, but remember, there's damage that was done. We owe it to each other. If it's your own aircraft, it's an aerobatic aircraft, you fly it within its limits. If it's not an aerobatic aircraft, fly in its limits. Your 5 seconds of fame is not going to impress anybody, except the front page of the news. Nobody else. All right. The beta range in the velocity sector is only 10%. So we haven't got much margin there. This area here, this one here, this is where a lot of people have lost their lives, because once the flutter is set on, they obviously get a fright. It doesn't matter what you do, flutter will just increase until the aircraft just literally rips itself apart. And that's another lecture on its own. So be aware of V and E. Never cross the V and E line. You owe it to your family. Okay. Leads to flutter. Flutter. We don't know. There's no guaranteed escape procedure for flutter. Okay. Stream flying in the corners is limited by the Buffett corners. Steepness limit will have negative results. Maybe not right now, but underlying damage has been done. When an overspeed is encountered by mistake, maneuvering Gs must be minimal to nil. So sometimes we actually sit and you didn't really pay attention. One of these super duper slick aeroplanes of today, you're diving and all of a sudden you look inside and you already passed the V&E. What are you going to do now? Well, don't pull, don't get a fright, don't do anything. All that you need is to very, very, very gently get this throttle closed ever so slowly. And ever so slowly, you must catch that nose so that there's no movement, no movement, no movement. Very, very, very slow. Any harsh maneuvering and the onset of flutter is probably guaranteed once you're over there. So be careful. If power is still on, obviously you've got to reduce it. Well, in conclusion, the knowledge of your machine's so the limits equates to life. Knowledge is life. Later on, I see speed is life. And you'll say to me, okay, so everything, these are the main ingredients of life, whether you like it or not. Remember, your permission was never asked for this. This is creation. You've got to respect it. But if you don't respect yourself, why would you respect nature? So go and look at the man in the mirror and ask that man in the mirror, what is your problem? And if you know that you do not know, be the man that you should be and find out so that you get to come into the know. That is important. All right, I'll just say here, remember, in order to live to fly, we must firstly fly to live. I simply get more and more passionate about flying by the day. But remember now, if I can only fly when I live. There's nothing else. And if I want to, look, I do understand that I haven't got full control over everything that happens to me. But I was given the power of decision making, and to decide to stay in the rules and regulations will always give you a better chance. Always. Always. All right. So where are we now? All right. To say that fly is heaven and hover is divine. All right, that's an old saying between the fixed-wing guys and the helicopter guys, because the fixed-wing guys say that to fly is heaven, and then the chopper guys came up with something and they say, no, but that is divinity. All right, play with it as you like. You can do what you like, but neither heaven or divinity can be experienced unless we are capable to apply the truth. And what is the truth? The prestigious described. It didn't ask you, do you like the truth? It didn't ask you, do you like the... Applying the truth is what keeps us out of trouble. The truth will set you free. What does that mean? Well, quite simple. I know that I shouldn't smuggle with diamonds, so if I smuggle with diamonds, I'm not going to be free, I'm going to sit in jail. But because I don't smuggle, I can't go to jail for that. If I speed on the ground, I can go to jail. If I don't do this, blah, blah, blah. And that's all the rules. Nobody asks you if you're happy with the rules. The rules didn't ask. Nobody asked you about those rules. Yeah, in today's age, I understand that, we don't like that, and we've got an uproar about everything that we want. But the one thing that we cannot fight is science. Get a life. Get science. Okay, so that then is the end of the series of 5. What did I want to achieve now that you've seen the lot? First of all, that your knowledge has increased, that you've increased your skills, and now you know that which you do not know. You know about the skills that you do not have. And you're going to respect yourself. I know you love yourself, you titivate yourself, and you do funny things for yourself, but do you respect yourself? Do you give yourself the best chance of succeeding, of staying alive? And the best way is to follow the rules. Will there come a time that you may be outside the rules? Well, we do make slip-ups. But even when we make slip-ups, remember, there is subtle ways on how we must get out. Next series will definitely be on turning, and then we're going to do a series of climbing and descending and all the basics. But for now, go out there and apply the rules. Safety is an attitude.
We hope you enjoyed that aviation snippet with Charlie Murray. Please make sure to visit our website www.aviationauditing.co.za. Follow us on both Facebook and Twitter, and subscribe to our YouTube channel under Seams Studio.